Decentralized AI, powered by the Pi Network.
We're constantly told that the future of AI is all about smarter algorithms and just bigger and bigger data. But what if the biggest challenge isn't in the code at all? What if it's in the plug? Today, we're going to look at AI's next great hurdle, its massive thirst for power, and a really radical experiment that could honestly change everything.
I mean, AI is advancing at a breathtaking pace, right? But all that progress, it's tied to a very real physical limit, the energy it takes to power the whole thing. So what happens when the demand for all this intelligence outstrips the actual supply of electricity? Seriously, is the AI revolution about to hit a brick wall?
And just to be crystal clear here, the barrier isn't a lack of brilliant ideas. Oh no, it's a very real, very physical problem. The sheer amount of computational energy you need to train and run these incredibly complex AI models, well, it's just becoming unsustainable.
All right, so to really understand the solution we're going to talk about, we first have to get a handle on the problem. And it's what some people are calling AI's hidden power crisis. And look, it's not just about how much electricity it uses, it's about the fundamental strain that AI is putting on our traditional centralized computing infrastructure. You see, the old model is really showing some deep cracks. For one, there are physical limits, right? You can only build these massive data centers so big and so fast, and they create these huge concentrated energy demands in single locations. But the problems are also technical. You've got things like catastrophic forgetting, which is wild. It's where an AI model learns a new skill, and in the process, it can literally erase an old one. And then there are global state bottlenecks, which are basically like massive traffic jams for data that slow the whole system down to a crawl.
Okay, so if the old way is hitting its limits, what's the alternative? This brings us to a really radical idea. What if, instead of building more and more massive data centers, we could just tap into the incredible computing power that's already out there? The power that's sitting idle in millions of computers all over the world.
Yeah, the Airbnb for computers analogy is just a perfect way to think about this. I mean, most of us have processing power on our machines that just sits there, completely unused most of the day. Decentralized computing basically creates a marketplace for that power, letting people like you and me rent out our spare capacity to those who really need it, like, say, AI companies. So this really shows you the fundamental shift we're talking about. We're moving away from a world with just a few massive, centralized data centers to a vast network of individual computers. Instead of concentrated power, you have distributed and shared resources. And maybe the biggest deal of all, the barrier to entry isn't billions of dollars for a new data center, it's just having a computer and deciding you want to join in.
Okay, so who is actually trying to build this Airbnb for computers? Well, this is where Pi Network enters the picture. And they argue that they are in a completely unique position to turn this whole theory into a reality. Mostly because they've already built the foundation for it, a massive global distributed network. And when I say massive, I mean it. The scale is kind of staggering. We're talking over 421,000 active community nodes. And remember, these are individual computers run by regular people all over the world who are already connected and forming the backbone of what could be a global supercomputer.
So what does that actually mean in terms of raw power? Well, it translates to over 1 million CPUs. Think about that. 1 million individual processing brains, all of which could be harnessed for really complex tasks. The scale? It's already there. So here's how it works in practice. Pi Network is exploring what they call a decentralized computing utility. And it's pretty straightforward. It's an opt-in system. Node operators can choose to lend their unused computer power for tasks like AI training. And this is the crucial part. They get compensated for it in cryptocurrency. So this isn't just about volunteering. It's about actually participating in a new kind of economy.
Okay, so theory is one thing, right? But the big question is, can it actually work in the real world? Well, let's look at the proof. Pi Network recently ran a pilot program to test this exact idea out, and they did it with a really fascinating partner.
The client for this test was a company called OpenMind, and what they're doing is building something they call an Android OS for robots. Now, teaching robots how to see and interact with the world, that requires a staggering amount of computing power for AI training. That made them the absolute perfect test case for this whole concept.
The experiment itself was actually beautiful in its simplicity. Here's how it went down. First, OpenMind sent a task out to the network, basically identify objects in these images. Second, volunteer Pi nodes accepted that task and used their own computer's power to run OpenMind's AI model on those images. And third, they sent the results, the objects they found, right back to OpenMind. Simple as that.
So this really is the million-dollar question, isn't it? Could this scattered, volunteer network of regular home computers actually perform a complex, real-world AI task for a paying client? Did the theory work in practice?
Okay, let's dive into the verdict from the test. The results from this proof-of-concept pilot are in, and believe me, they paint a very, very clear picture.
Honestly, the results were really impressive. Now look, only 7 volunteers participated in this very first initial test, but the speed was remarkable. A job was acknowledged across the network in less than 1 second. The actual inference results came back in under 4 seconds, and most importantly, they were accurate. The nodes correctly identified objects like bus and person. Bottom line, the system worked.
So the conclusion here was completely unambiguous. The test proved it. It validated the core idea that Pi's distributed network can reliably execute complex AI workloads for third-party clients. This wasn't just a theory anymore. It was a proven concept.
Okay, so what does all this mean? What happens if your PC joins? Let's zoom out and really look at the bigger picture here. Not just for the world of AI, but for individuals, for pretty much anyone with a computer.
Well, for starters, this creates a whole new option beyond the traditional data centers. It takes all that scattered and unused computing power out there and turns it into something valuable. But maybe the most important part is that it creates an opportunity for equitable participation. It allows regular individuals to actually contribute to the AI economy and get paid for it.
And it's not just about CPUs. The potential here actually goes even deeper. See, Pi's network has tens of millions of verified users, real people. This could provide authentic human input to train even smarter AI systems. You get real people providing feedback, helping make AI not just smarter, but more aligned with what we actually want. It's a pretty big deal.
And all of this brings us to a final, pretty thought-provoking question. We've seen the problem, right? AI's hidden power crisis. And we've seen a potential solution that's actually been tested in the real world. This experiment points to a future where building the next generation of AI isn't just something that happens in some far-off, mysterious data center. It's something that could happen in a small way on millions of computers just like yours. So the real question is, could your computer help train the next generation of AI?